Ecosystem, in the interest of time, I'll just briefly go over the concept of our ecosystem research. In the biological preservation community, there's always been this fortress mentality where if you wanted to preserve an ecosystem or you want to preserve biodiversity, you built a big wall and you kept the biodiversity in and you kept the people out. There's a growing realization that in a lot of the developing countries around the world, that's not necessarily a feasible solution. You can't simply continue to buy up land and expect people to be pushed out of that land. And so we are working on a project called Advancing Conservation in a Social Context, which is looking more at how you can make biodiversity a valuable resource for populations in 3 different cultural contexts. So we're going to 3 different cultural developing countries. We're looking at Tanzania and Africa, Vietnam and Southeast Asia, and Peru and South America, and working on strategies to incorporate society with biodiversity and advancing biodiversity and conservation in that social context. We have a very active program in our university operations, making sure that what we are doing is consistent with what we are preaching. And so that includes minimizing the environmental footprint of the university, emphasizing carbon neutrality, and focusing on zero waste. I'll talk a little bit about some of our solar installations in just a second. But when we talk about global energy, I wanted to come back to this theme, that if you look at the track that we're on, this is from the Energy Information Agency, and this is a little bit outdated, but I don't think anybody will necessarily disagree with this. Unless we change something quite dramatically, we will continue to rely on fossil fuels. And this is from 2003, but the projections are that we'll continue to be increasingly reliable on oil, coal, and natural gas, maybe have a slight increase in renewable energy. And this is for all forms of energy use. And the focus is we have to get off this trajectory. We have limited supplies of petroleum. We have limited environmental ability to absorb the pollution associated with these traditional fossil fuels. And so we need to get off of those. And so one of the focuses that we have is on solar research. Again, solar research at ASU has been around for a long time. We have very broad categories of research. Everything from fundamentals materials research, those are just some photonic band gap heterostructures that I grabbed from our School of Materials, which is looking at how you build the semiconductors and how you manufacture them and how you engineer those systems to actually capture the photons from the sun. We have a work on integration of distributed generation into electrical infrastructure. I can tell you today that if everybody in the city of Tucson put a solar panel on their roof, the electrical distribution system would crash. You would not be able to incorporate a large penetration of distributed generation into our current engineered infrastructure. But we're looking at the future. As renewables become increasingly reliable, how do you integrate those into our existing infrastructure, and how do you improve our existing infrastructure? I'm talking about wires and transformers and substations and things like that, so that we can rely increasingly on electric. Our partners in the Future Renewable Energy, Electric Energy Delivery and Management Center, which is an engineering research center focused on this. But we're also doing things like how do you put photovoltaics onto built structures? We actively work with our College of Design and how to incorporate active and passive solar into building structures. This is actually one of the parking structures at ASU. And the new installation of photovoltaics on top of that, on that structure, and it's part of our solarization project. But beyond that, we also are looking at urban design. Again, kind of with our focus on urbanization, it's clear that low-density urban development is associated with increased use of energy. I'm not saying that we're going to build places like Singapore or Tokyo or Hong Kong, which have a relatively high population density, but relatively low energy consumption. We have to look at something that's locally relevant and locally feasible. And so we're working with the Phoenix Urban Research Lab, studying the relationship between urban design and energy consumption to provide strategies that make sense in a local context. Again, we're not going to replicate what's going on in dense Asian cities, but we can look at strategies appropriate here in the desert in Arizona to build urban infrastructure that minimizes energy consumption. Global energy. Again, this topic is on global energy, and so I want to stress that the graph I showed you was marketed energy, which is energy that is sold, but a surprisingly large fraction of the population, over 2 billion people in this world, rely on biomass for their energy source. And that's a real concern, partly because of deforestation, but also because of local health effects. And so Global Resolve is an organization at ASU which is working in less developed countries to devise energy solutions that are appropriate and sustainable. They have programs working on jatropha biodiesel and gel fuel production in Ghana. The idea is instead of relying on wood combustion for cooking in a house where you get exposed to the particulate associated with that, developing a sustainable energy solution, whether it's jatropha or algae-based fuels, so that you can replace that and be cleaner. And I want to also point out that Global Resolve is not just about research and outreach, it's also about education. And that's kind of one of the themes that we have, is integrating education and student training in all of our types of projects. Finally, I want to bring up power and water. Again, I talked about power. Everybody knows that power is associated with climate change, but it's also associated with water. If you look at the Central Arizona Phoenix project, which supplies water here for the metropolitan Tucson region, it takes a lot of power to pump water from the Colorado River up here to Tucson. It takes about 640 kilowatt hours to supply water for one person for 1 year through the Central Arizona project. Producing electrical power in the desert also takes a lot of water. When you generate heat, you have to cool that heat. And if you look at APS, which is our power supplier in Phoenix, the APS, it's about 7.7 gallons per kilowatt hour. Again, you have to have water to produce power from the desert. And so if you look, an urban, it's a little lower here in Tucson. The average person in Phoenix uses about 250 gallons per day. But about 7 or 8% of that actually is incorporated in the water that's used for power generation, for supplying the electrical power to a person. Water for power, power for water is actually about 6%. And all I wanted to point out here is that it takes water to make power, and you have to use power to pump water. And the two are interrelated. And so we're increasingly focused on the interrelationship between power and water, especially here in Arizona and the desert Southwest. So with that, I'll just leave these up, and I'll be available for questions afterward.
Our last speaker this morning is Stephen Dwyer, who is a civil engineer with Solar American Cities. He received his BS degree in civil engineering and his MBA from New Mexico State University, and then received an MS and PhD degree in civil engineering from the University of New Mexico. He's had over 25 years of engineering experience in multiple fields dealing with the environment, structural, and renewable energy. And he's worked on solar thermal research and development at Sandia National Laboratories in Albuquerque. So thanks very much, Steve, for being here this morning.
Hi, again, I'm Steve Dwyer. I work for Sandia Labs in Albuquerque, and I'm going to talk a little bit about a program that we've got going called Solar American Cities. First, I was just going to show you a little bit of the chart that came out of the report that you see listed up there. It's a global energy use and broken down by where it comes from. You can see fossil fuels is by far the majority of where we get our energy. When you get down to renewables, you can see it's only 6.7% of the entire market. In my area that I'm dealing with in Sandia is in the solar field. And as far as total market share of the global economy, we're less than 0.1%. We're 0.08% of the entire market share. I went to an interesting talk a while back. This guy, a professor from MIT, he's doing a lot of research in storage of renewable energy, specifically related to solar. Anyway, this is a chart that he put up, and I borrowed from him. Back in 2000, the global energy use was about 12.8 terawatts. You can see how it's broken up, predominantly oil, much less renewable. Now he ran it out to 2050 and basically used the formula on the right that's really a function of population growth, gross domestic product, and energy use, or in the more or less the conservation that will come into play. Came up with a growth rate for a global energy demand of 1.5%. So what I did there is I just rolled that over into what we would be needing as far as market share within the solar group to build our program to meet some of the current demand that's out there. And I rolled it from